Bismillahirrahmanirrahim. Hello everyone. I hope you are all doing well. My name is Azmat Ali. I welcome you all to the class of O-level mathematics. Our discussion is continue on linear inequalities in two variables. In the last lecture, we discussed about some basic concepts and definitions related to linear inequalities. In that lecture, we also discussed how to shade the given linear inequality. In today's lecture, we are going to discuss how to find or how to shade the solution region when we have a system of linear inequality. What do you mean by the system of linear inequality? Two or more than two inequalities form a system that is called system of linear inequality. So we discussed a problem: shade the solution region of the following system of linear inequalities. We have given two linear inequalities. Suppose this is our first inequality and this is second. First of all, we find the associated or boundary lines of these two inequalities. Boundary lines of 1 and 2. Boundary line or associated equations can be found simply by replacing less than or equal and greater than or equal sign with equal sign. So the associated or boundary lines of 1 and 2 are x minus 2y is equal to 6. This is the boundary line of 1. In the similar way, we can find the boundary line of 2, that is 2x plus y is equal to 2. Yes. Okay. Next, we convert these two boundary lines into two intercept form. We know that equation of the form x over a plus y over b is equal to 1. This is called two intercept form of line. Here the number in the denominator of x, that is a, and is called x-intercept, and the number in the denominator of y, that is b, is called y-intercept. So to find the two intercept form of this boundary line, we just divide both sides by 6. We have x over 6 minus 2y by 6 is equal to 6 over 6. This can be written as x over 6. After cancellation, we can write it as y over minus 3 is equal to 6 by 6 is equal to 1. In the similar way, when we divide this line by 2 on both sides, we have 2x by 2 plus y by 2 is equal to 2 by 2. This is x over 1. Y over 2 is equal to 1. So this, suppose this is 3 and this is 4. Now what is the x-intercept of 3? X-intercept is the number in the denominator of x, that is 6. Y-intercept is here minus 3. Similarly, the x-intercept of 4 is 1, and y-intercept is 2 here. Next, we locate these two intercepts of both lines on x-axis and y-axis. So next we make x and y intersect here. This is our y-axis. Suppose this is our x-axis. Origin. This is y-axis, and this is negative y. This is negative x. Next, x-intercept in 3 is 6. This is x is equal to 1, x is equal to 2, x is equal to 3, x is equal to 4, x is equal to 5. This is x is equal to 6. Suppose this is x is equal to 6 here. And the corresponding y-intercept is minus 3. This is y is equal to 1, minus 1, minus 2, minus 3. This is y is equal to minus 3. Next, we join these two intercept by a solid line. Remember here, as in our both inequalities, inequality number 1 and inequality number 2, there are greater than or equal sign available. So when we draw the graph of the boundary lines 3 and 4, this will be a solid line, like as by joining these two intercept we get the straight line. So this is the graph of the straight line opposite to this equation, x minus 2y is equal to 6 or 3. So this is the graph of x minus 2y is equal to 6. This boundary line is actually the graph of x minus 2y is equal to 6. Next. Next we draw the graph of 2x plus y is equal to 2. This line has x-intercept 1 and y-intercept 2. Where is x is equal to 1 here? This is x is equal to 1. This is x is equal to 1 here. And where is y is equal to 2? Y is equal to 2. Suppose this is y is equal to 1. This is y is equal to 2. So by joining these two intercept again, we have a boundary line like this. So this is the equation of 2x plus y is equal to 2. This is the line opposite to 2x plus y is equal to 2 here. Next, as we have to shade the common region between these two given inequalities, our target is to shade the solution region of the following system of linear inequalities. So finally, to shade the solution region of the given inequality, first inequality is x minus 2y is less than or equal to 6. To find the direction in which we shade, in which direction we will shade the given inequality, we take a point that we usually take 0, 0, that is called test point. You can take any point other than 0, 0, but origin is convenient for us. So by putting x is equal to 0 and y is equal to 0 in the given inequality on the left side, this will become 0 less than or equal to 6. Whether this inequality is true or false? This is true. You know 0 is always less than 6. This shows that when this is true, this shows that the graph of this inequality is towards the origin. Where is its boundary line? The boundary line of x minus 2y is equal to 6 is this. So its graph will be towards the origin. Where is origin? Origin is here. So graph will like this, towards the origin. So we shade this to the above of this line. Like this. Towards the origin mean like this. Next, our second boundary line is 2x plus y is equal to 2, which is opposite to this 2x plus y is equal to 2. I change the color here, suppose this is our second line, 2x plus y is equal to 2. What is our second inequality? Our second inequality is 2x plus y greater than or equal to 2. 2x plus y greater than or equal to 2. To determine the direction, whether it will be shaded towards the origin or not, we just put here x is equal to 0 and y is equal to 0 in the given inequality. This will become 0 greater than or equal to 2. This is false. 0 is always less than 2. So what does this represent? This represents that the graph of this inequality is away from the origin. The graph of second inequality is away from the origin. Mean to say, we will not shade it towards the origin. So its graph will be away from the origin like this. This one, away from the origin, because origin is here below this line. So we will shade away from the origin. So here the common shaded region between these two inequalities are the rectangles that are here formed by these purple lines and yellow lines. So this is the common region. Every point of this common region will always satisfy both of the inequalities. Suppose, as you can see that this common region, some of the area of this common region lies in first quadrant. If you choose any point from the first quadrant, suppose you take x is equal to 3, y is equal to 2 here. If you put x is equal to 3 and y is equal to 2 here in any of the given inequality, you can see that this will satisfy the given inequality. Suppose x is equal to 3 and y is equal to 2. If you put here x is equal to 3 and y is equal to 2 here in the first inequality, here 3 minus 2 into 2, this is equal to 2 to the 4. 3 minus 4, this is minus 1. Minus 1 is always less than 6. This is true. If you put this point in the second inequality, 2 into 3 plus 2, this is 2 plus 2 into 3, 6. 6 plus 2, 8. 8 is greater than 2. This is also true. So The common region or the shaded region here shows the solution region of the given system of linear inequalities. This shows that any point of this solution region will always satisfy the given inequality. I hope today's lecture is beneficial for you, and now you have a clear understanding all of your doubts.